Now, in these last three examples, we see that there's a little bit more going on. Not only do we have an inverse sine or inverse cosine or inverse tangent of something, but then we're taking some trigonometric ratio of that. And these are not ratios that appear on our unit circle. 3/5, although we should recognize that as being part of a Pythagorean triple, is not a ratio from our unit circle. Neither is 5/13 nor 3/8. Now, that doesn't mean that we need to use a calculator for these questions. In fact, we don't need one. Now, what we have to, again, remember is that when we take the inverse sine of something, or the inverse cosine of something, or the inverse tangent of something, our answer is an angle. So this right here is some angle theta that has a sine ratio of 3/5. Now, I don't need to know what that angle is in order to be able to find its cosine based on the information that I'm given. What I can do is I can draw a triangle that has a sine ratio of 3/5. Now, I do have to be careful about how I draw my triangle, because inverse sine is going to give me an answer that is between negative pi over 2 and positive pi over 2, or if we think in degrees now, from negative 90 to 90. Well, since my sine ratio is positive, that does mean that my angle is going to be in the first quadrant. So here is my angle theta that we are being given information about by being told that its sine ratio is 3/5. So now I can label up my triangle as 3 for the opposite side to the angle and 5 as the hypotenuse. So now what I'm being asked is find the cosine of this angle. Since inverse sine of 3/5 is describing the angle that we've drawn here inside of a triangle that has 3 as the opposite side and 5 as the adjacent, well, now I can go ahead and find the cosine of that angle by knowing the adjacent over the hypotenuse. And since this is a 3, 4, 5 triangle, that means that the cosine of this angle, or ultimately the value of this expression, is 4/5. Taking the same approach on the next one, so I'm going to forget about the tangent part of it, and I'm just going to concentrate on the angle that's being described here, which says that the inverse cosine of this, the angle that we're talking about here, has a cosine ratio of negative 5/13. Now, if we think about where that angle must be located, inverse cosine gives us an answer between 0 and pi, between 0 and 180. Well, if cosine is going to be negative, that must mean that that angle is located in the second quadrant. So I'm going to draw our angle so that it is in the second quadrant, but then I'll use this reference angle as my tool to actually figure out what is the triangle that I'm working with. And so if cosine is negative 5/13, well, that makes the hypotenuse 13, because the hypotenuse is always positive, which must mean that that horizontal side there, the adjacent side, is the negative 5. So now, because I've drawn this in the second quadrant, that means that the opposite side is going to be positive, and hopefully again we recognize this as being a 5, 12, 13 triangle. And so now if I want to find the tangent of this angle that's described there in the parentheses when it says inverse cosine of negative 5/13, I'm going to take the opposite over adjacent. So my answer on this one is 12 over negative 5. For the last one of the bunch, forget about the secant, just concentrate on the tangent. So the inverse tangent is negative 3/8. So again, this is describing an angle. What's inside the parentheses there is describing an angle. So I need to make sure that I sketch that angle in the correct quadrant. Since inverse tangent gives me an answer between negative pi over 2 and positive pi over 2, or between negative 90 and positive 90, since my tangent ratio is negative, that means my angle must be located in the fourth quadrant. It must be all the way this way, or really we're rotating in the negative direction. So now I have to label up the sides. So if the tangent ratio is negative 3/8, well, that means this side here, let's try that again. My opposite side is going to be negative 3 but my adjacent side is going to be positive. It's going to be 8. Since from the origin here, we've got a point that's in the 4th quadrant there. So this time I'm going to, it's 3, 8. There's no Pythagorean triple that I can work with, so I have to use a little Pythagorean theorem. So 8 squared, 64, plus 3 squared, 9, gives me 73. So I've got root 73 is my hypotenuse. And so now I want to find what is the secant of this angle that is in our triangle here. And so the secant of that angle is going to be the reciprocal of cosine. So instead of adjacent over hypotenuse, we're going to go hypotenuse over adjacent, and we're going to get root 73 over 8. The risk on these questions is if we don't draw the triangle, if we don't draw the angle in the correct quadrant, then we are going to end up incorrect on the positive or negative sign of our answer. So for example, on this last one, if we had drawn this to be in the 2nd quadrant instead of in the 4th quadrant, if we had drawn it to be between 90 and 180 for the angle, instead of as it should be between 0 and negative 90, as the inverse tangent gives us, then we would have ended up with an incorrect positive negative sign. We would have gotten a negative answer because cosine, and then therefore its reciprocal secant, would be negative in the 2nd quadrant, but indeed we're supposed to get a positive answer for this question.